Thanks for joining. Today we are in day number 6. Today we have very important topic related to high availability within the campus area. So how we can go and do the designing for campus area network. And these drafts that you are seeing here, these are taken from Cisco website. This is Cisco best practices, and you will see that most of the companies organizations, they are using same type of design, backbone design in their infra. At this point of time, from our CCNA and CCNP knowledge, we know that we have 3-tier architecture. Means if you are using 3-tier architecture, then you have 3-tier architecture. In that 3-tier architecture, you can see that you have core, distribution, and access. Now, this core, distribution, access with respect to campus design, what is the significance, how it is working, what are the rules you will go and define at what particular layer, everything we are going to discuss. And then we'll see that what will be the best practice design when you'll go and connect campus and WAN and data center and internet edge, all those things. If you go and fit within one big giant design, and in other terms, if we are referring Cisco, so Cisco validated design, then how it look like. So those things we are going to discuss today. Okay, so let's get this started. Now in this diagram, you can see that this is the core or the backbone. Within that, you have this core layer, and everyone knows that what is the use of core, distribution, and access. In loose term, core layer is something which is, you can see this is common with all the distributions. That means that from distribution layer, you are doing some sort of aggregation related to routing, and then it is coming to the core layer. And from core, you can see that I have core backbone. From there, I'm connecting to WAN, data center, internet edge, right? So this core that you're seeing, again, we'll go and discuss more and more about this. And this is just the design, high level design. So this core that you're seeing here, this core backbone, and when you will go and connect this with the internet, obviously you have to go and use different type of other appliances as well, such as firewall, load balancer, application accelerator, etc., etc. Right? Then you can see that from core you can go use some WAN transport in between. You will reach to data center. Within data center you have servers, storage, different type of data center fabric devices such as Nexus operating system. You may have compute devices, etc., etc. Means this data center itself is a big area, and that will be covered in the CCD, a specific CCD train. So in CCD train, I will go and explain how data center design look like, how we can go and create the HLD and LLD related to data center. At present, at this point of time, in data center, the trending architecture is leaf spine architecture. So either you use Nexus based leaf spine or any non-Cisco leaf spine, or you can go and use ACI based architecture. But either it's a ACI based architecture or non-ACI based Nexus architecture, we are using leaf spine within the data center. And then how different branches will go and connect. So that is your WAN connectivity. That is also one specific design in all the organization, that how you're designing the WAN. In our course, we have this part. In CCI Enterprise, we have to learn about legacy WAN and the next generation WAN. Legacy WAN means that you have to go and learn about the DMVPN. DMVPN technology we are going to discuss. We have lab related to DMVPN. In exam also you will see questions related to DMVPN. And then we have to go and learn the design principles and the configuration for SD-WAN. So this part, in this particular exam in CCI Enterprise, you have full coverage related to this part. This part is coming within CCI data center. And this part actually, this is one part. Most of the topics, they are covered in CCI security. Because when you're exposed to internet, you have to go and apply different type of firewalls, different type of security devices, different type of security analytic devices. Everything will go and fit here in the internet edge. So there you have to put more and more security, right? So except data center and internet part, we have to go and learn everything here in our CCI enterprise. So how WAN look like, how campus fabric look like, how you can go and configure the core devices, where you will go and place different type of services. Everything you have to learn, the first of all the design related to this, and then later on you will see that in the configuration section we'll go and create one big giant lab with 4 branches, one data center, few HQs, and then in between you have transport related to MPLS, transport related to MPLS or maybe broadband as well. But over that transport, we have to go and connect different branches. Few branches will go and use SD-WAN, and few branches will go and use the internet connectivity as a transport, right? So we are going to focus more and more in this area. And good thing about this in our lab, that this coverage area that we have, so the management plane that we are going to use for entire LAN devices or LAN fabric, that will be DNA in our exam. From DNA, we have to go discover all the devices. From DNA, you can go and manage all the devices, configuration and compliances. And then from SD-WAN, we have to go and manage the wide area network. And DMVPN, we are going to manage the non SD-WAN devices. Like that, we will proceed. Okay. So now, before going there, what we have to do today? Today we have to go and learn about the role of core layer, distribution layer, access layer, and how we can achieve high availability and redundancy in terms of core, distribution, and access layer. Now, again, before going there, you can see this access layer switches. So access layer switches, and in CCNA days, we used to learn that we have network terminating devices. Network terminating devices means that your network will end there. So where your network will end? Where you will go and connect the endpoint devices like laptop, printer, those devices which is non-networking. So there you have to go and connect. So whatever place you'll go and connect those non-networking devices, there your network will go and end. If you go and connect switch to switch, that means you are extending your network, because those are networking devices. Okay, so now you will see the criteria or a specification related to access layer. So access layer switch, I'm going to connect the devices which is term as endpoint, and which will go and terminate the network, such as IP phones, such as handheld devices, laptop, PCs, printer, etc. So those devices where we are connecting, we are connecting to the access switches, access layer switches. So now again you can think, oh, so access layer switches may be vulnerable because you have 2000 access layer switches, because obviously you have so many endpoints. According to that, you have access switches. And in this diagram, you can see uh, only wired based switches, right? But you may have, so if I go here and draw one more box here, for example, and in this box, if we go and connect one tower, like you may have APs. Suppose this is access point. So access point will also work as a access layers switch or router, whatever we can think. But with this access point, again, you can go and connect the laptops or other wireless devices. So point here is this, that either it's a wired or wireless network, access point or access APs access points or this access switches, they may be vulnerable to do certain attacks, either internal or external, because they are spread across the geography, means even in same building also you have so many switches and all. And other thing is that they are little bit lightweight devices, means they are little bit less expensive than these big boxes. And these big boxes, you can go and enable so many different security features that maybe you will not go and enable those big security features in those access switches. So how we can consider this security as well, and what type of security protocol as well I can go and enable in the access switches, because in a foolproof network, if you are securing your core layer, you should secure your distribution layer and you should secure your access layer as well. Otherwise, someone can go create some backhole, and then from your access layer, they can try to compromise the distribution, and from distribution, they can compromise, not compromise, but you can say that bypass. So they can bypass the distribution, bypass the core, and somehow they will go and reach to data center servers. Right. So these security measures are also very important. We'll go and see that in access layer switches, also you can go and enable different type of security. So when you're seeing the network, you do not see just like it's a connection of routers, switches and all. You should see that in terms of security as well. You should not have security loopholes within the network. So let's go and see the rest of the slides. Yeah. So far, you have any question? All right, let's move on. So now you can see that this is one poorly designed diagram, and you will see that now you can see this diagram, and now we'll see this diagram. In this diagram, not only you have a core layer, a distribution layer, and access layer, but if you see this diagram carefully, you will see that you have at least two types of redundancy here. One type of redundancy is called device layer redundancy, and other type of redundancy is termed as a port level redundancy or interface level redundancy. So here you will see in this diagram that in all the layers we have two devices. In core layer you can see pair of devices. In distribution layer you can see pair of devices. Since you have pair of devices, then you have four links. So from one link from one distribution layer, it is going to core layer. So one link in core this and one link is going in core this. So two connections we have, right? Likewise, you can see we have two connections like this. Now, question here is this, that why we have this multiple connections, and if we have this multiple connection, then what we are achieving here? What's the goal? You can answer.
Redundancy.
Redundancy is the goal, yes. So if any device will go down, then still you have other device as a backup device. That is one thing. Other enhancement, other thing you can see here. Other point. Okay, I'll give you a hint. So if you see this diagram, it is not mentioned in this PPT, but if you see this diagram, you'll find that this blue color cable that you can see, all these blues, they are L2 connection. And the other color cable that you can see here, this reddish type of color connection that you are seeing, this is L3 connection. So blue and red, L2 and L3. So that means within core and distribution, the communication channel that we have is L3, is routed. What is the advantage when we are using this routed connection?
The advantage is that there's no spanning tree in the
There is
routed.
no spanning tree here, 100% right. So in layer 2 design, by default, they will use STP. That means
Mm,
that 50% of link will be unutilized because 50% of link will be in the disable mode. They will not send the traffic. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 8 links shown here, but still you will see that traffic is passing only with the 4 link. That means that we do not have full-fledged bandwidth utilization, right? If you have L2 design. Now, on other hand, if you see this L3 design and you are running any protocol, OSPF, EIGRP, ISF, whatever protocol, in that case, there is one very important term called ECMP, equal cost multipathing. So what ECMP is doing, that first of all, that the connection that you suppose if we are running OSPF in between core to distribution, right? And if you are running OSPF and if OSPF running in default mode, so both link will be active. It's like that. Later on, it's up to us and we will see that in our lab, we are making one link as a primary, other link as a backup. It depends upon design and all, but generally we don't want to do that because we want to utilize this link bandwidth. So we are making these links as a active, and one of the feature with L3 protocol is this, that they are doing, they are supporting equal cost multipathing. Okay, so that is one very key point here that I want to raise. Now let's go here to the next slide and we'll see that one poorly designed network. You can see that there is no clear demarcation that which is the distribution layer, which is the core layer, which is the uh, access layer, etc. Access layer, although you can see that where you are connecting the terminating devices, but still you can see all access switches in this section. In section number 3, this portion you will see that all access layer, again they are connected with access layer, and one access layer is going to other access layer and then it is going to distribution, like that. If you have any type of STP loop here, a spanning tree loop here, or layer 2 loop here, it's very difficult to identify that which particular switch you are sending the frames and receiving the frames, because this is poorly designed network. And other thing here is this, suppose if this switch will go, there is no redundancy, right? If this switch will go, then how traffic will go, reach. So if this switch will go, then you will see here that this site will be isolated, right? Otherwise the traffic will go from here to here and then here and then here and then here, like this. Like it has to go in wrong path. Like this is the longest path from one branch to other branch to other branch to other branch and then destination. Right? So this is poorly designed network. You will see not only layer 2 loops will get created, you will see that layer 3 loops also will get created. And there is no bandwidth or the link redundancy like you have here, and there is no device redundancy as well. So we should not design network like this. We should design network in a fashion that it should be defined. So in this network, there is one more advantage. Advantage is this, that suppose your core devices, they are lacking of bandwidth. That means all of a sudden business has grown and you need more bandwidth, more port capability. So what you can do in better design network, that simply you put one more box here, and then that particular box will go and connect with rest of the devices, and the connection will be very easy. You can go simply connect like this, and then you can go and connect like this. So what you are doing, simply doing the physical cabling, and same type of configuration that you have here, same type of configuration you can do, put here. There is no problem in that. Only your interfaces will get changed. But all of a sudden you can see that redundancy now is threefold. Port capacity got increased, and expanding this network is very easy, rather than if you go and check how to expand this network. It is very difficult to expand the network as well. So not only the redundancy, high availability, bandwidth utilization in terms of ECMP, equal cost multipathing, but you can expand the network as well. You can expand the devices, you can expand the port capability as well, ports as well. Likewise, suppose all of a sudden if you have demand that you have to go and add some more ports. So what you can do, you can add one more switch here, and then that particular switch will go and connect like this. So in access layer also you can go and increase the number of devices, port capability without any downtime. You don't need any downtime, you don't need anything. Just configure this switch, configure the interfaces, connect with this, configure the interfaces here, and then it will start working. Right. Likewise, you can go and add the distribution switch as well. If you add the distribution switch, then you have to do some routing in between them, and then you will go and connect to the core layer switches. So that's the advantage with the good design, means better design network, rather than if you have to go and add something here, it will be headache. See, here you can see that you have access layer redundancy as well. Here you don't have access layer redundancy. So tomorrow, if this link will go down, these devices will be isolated, right? This switch is isolated because there is no extra pair of distribution switch where I can go and connect the devices. If I go and connect like this, it will form the loop here, right? And if suppose if this is down, then what will happen? All these hosts will go because this is connected to single switch, right? And if single switch having reboot issue or failure issue or anything, that means all these hosts will go, become offline. So this is very, very bad design. Even if this distribution will go, all these devices will go offline, right? So that's a good design and bad design. You have to sit and plan more redundant, better design, but we should consider some other things as well while doing that design. So far, if you have any question, please ask. All right, it is so
So,
far. Yeah,
yeah, I have a question. So, uh, in the good design, like my company like that, can you show the good design, like the first one? Yeah, in my company, the blue section for the access layer, we are also doing routed for that too.
yeah. So I haven't come to that point
Oh, okay.
where we should use a routed fiber. So DNA, when we are using DNA is
Mm-hmm.
using a routed underlay, a routed
Okay.
campus layer networking, and then
Mm-hmm.
we have some sort of VTIP. So these devices are working as a VTIP, and then we have VXLAN here in the LAN section as well. VXLAN encapsulations and that, you know. So this is okay, good design, but this is not the best design.
Okay.
And we'll discuss about that as well in upcoming section. We have
Okay.
design related to LAN as well. So this is one of the better design. You can't, this is okay, good design, no doubt about that. But this also get evolved to
Mm-hmm.
routed. Why? Because you have seen the issue here. So what's the issue
Mm-hmm.
here? 50% of link you are not utilizing.
Mm-hmm.
So why not using L3 protocol here to get to
Mm-hmm.
utilize this unutilized links, and here
Correct.
also you can go and use ECMP. So that's
Okay.
right. In SDA, in DNA fabric, we are using L3 routed in the LAN area.
Okay.
Okay, so that's a really good question. But with compared to this is better design, right?
Yes.
That's the point I want to. All right, so let's move on slowly, and let's see. You have different design and evolution, and why this design got evolved. Each and everything we will discuss later on. Okay, so now let's quickly move on and let's see a few points related to this. So you can see that if you have this three-tier architecture, then it will offer you hierarchy, modular topology, easy to grow that we have discussed. Fault tolerance is easy. Isolation of fault is also easy. It will promote you load balancing and redundancy. We'll see that where you can go and use GLBP, HSRP, VSS stack. Now we are using VPC in data center, but in the LAN you can go and use some other technology as well. We'll see that. Incorporate balance of both L2 and L3 technologies, utilize layer 3 routing for load balancing. Means all sort of good features we have if we are using this three-tier architecture. This is a list of those features that we have discussed as well. Now let's go quickly and see that core distribution access layer, what type of protocols we can use. So you will see here that we can go and use layer 2 feature. Now you can see this diagram that this is highlighted in the bottom. That means we are discussing about the access layer features. So in access layer, you can go and use HA, high availability security, QoS, multicasting. Then you can go and use QoS, broadcast separation, IGMP snooping. All these are configurations. You can go and configure these. Then we can go and use PBST plus. Uh, in our lab later on, you'll see that we'll go and use MST, multi-instance of a spanning tree, and why we are using it, what's the advantage, we'll see that. Then we'll go and use the ether channel. We have PAGP, LAGP. We'll go and use the LSCP in our lab. We have EIGRP, we have OSPF, we have VTP configuration. This is DTP, but VTP configuration. Like that, I think we are going to cover at least 80-90% of whatever features we have in the access layer. Apart from that, you can see that we can go and use the security features. I told you earlier that access layer switches may be the bottleneck for the security. You can't leave the security features here in access layer. So you can go and use some tag-based ACLs. Once you are integrating these switches within the DNA fabric, within the SD fabric, then even you can go and do some sort of micro segmentation as well. So port security, DHCP snooping, we are going to use DHCP snooping. We'll study about DIA as well. IPSG, these features will use, and few of the features will go and perform the lab as well. In our lab, we have those, in our exam, we have those labs as well. Apart from that, phone related, IP phone related configuration, STP related configuration, and STP protection related configuration. All these things you can go and use within the access layer switch, right? Now, what are the features related to distribution layer switch? Means what are the things you can go and enable? Now you can see that it is circled here in the distribution layer. So distribution layer, one of the most important thing we have that this point, aggregate wiring closet and uplink to the core. So this is something like sandwiched in between core and the access layer. So it is providing the services to the access switches as well, plus core switches as well. So you can see that in this diagram, in this particular design, your design may be different, but in this particular design, you will see that from distribution to core, we have routed configuration. And these links are routing. So we are doing some sort of routing configuration here. And then here you can go, even you can do routing as well. But in this diagram, they are L2 configuration. So it will go, you can go and provide QoS configuration. It will work as a aggregator because so many interfaces will go and connect here. So maybe hundreds of switches, they will go and connect here in the distribution layer switch. So that's why when you are selecting distribution layer switch hardware, you should consider the port density as well. Better go for some chassis based switches, chassis based big switches, where you can go and connect more and more switches, right? So do not go and choose 48 port switch or something like that. Go and use some big switches, because it will work as an aggregator as well, where you have to go and connect so many different interfaces. Then it will go and protect. So let's go and check other features. Protect core from high density peering. You can go and do route summarization. Route summarization is one of the big topic. Why? Because in that case, you are protecting the control plane. Uh, Otherwise, the distribution and core layer switches, they have to go and resolve all the IP table, because they are building their routing table. So they have to resolve the entries within the routing table. So that's why in the core switches, we are pointing the default route as well, or better summary route. Do not unnecessarily grow the routing table for the core infra. Okay, and later on we have topic related to that, where we will learn about OSPF IP prefix separation. Okay, why we are suppressing the prefixes, just to protect our core layer routing table. Then it has different type of load balancing methodologies as well. Somewhere we are using GLBP, somewhere HSRP. In our lab, the big lab, we'll go and configure HSRP and VRRP. We'll see that later on. Then finally, you have core layer. In core layer, the distribution layer will go and connect, and from core, you have to go and connect different type of services as per this topology. You are connecting with WAN, data center, internet, etc. So that's why we are configuring. This is the backbone. It should have high performance and stability. All the distribution layer, they are terminating there. It is separating the different type of nature of network, right? Like WAN and DC and all, and keep the design technology independent. So better design should be modular. So you have this modular approach, that all the different boxes, they will go and connect in redundant manner, in the modular manner. Wow. So before we'll proceed further, you have any question here? If no question here, then you will see the design. Now, again, how we can go and make your LAN routed, that is one topic that we'll discuss later on. But now you'll see that evolve topology that we have from different design, that you have the core. No doubt we have discussed about the core layer. This is routed core. And then we have this routed distribution. You can see that you have WAN edge, you have DC edge, and then the network. You have internet edge and then the network. But all these highlighted areas, you will see they are routed, and there is one routed LAN as well in this section. So in your network, you may have a routed LAN, you may have L2 LAN. That's why you can see L2 access, routed access, or you may have virtual switching. Virtual switching is also L2, and that is something that will go and protect you from the STP issues. So what these virtual systems are doing, so here you know clearly that 50% link is disabled. 50% of link, they are disabled. But when you are using this VSS, virtual switching, so you can see that some sort of ether channel is there. So you will see that the topology, although the topology is Suppose this is distribution layer switch, and then I'll go and draw some 1, 2, 3 access layer switch. So although you can see that we have this type of connection, like redundant connection, you can see, but behind the scene, what is happening in this design, that this will be one box. If we have pure VSS, and then instead of triangle connection, we have single connection that is going to one switch like this, like this, like this. So where we are forming STP? We are forming STP when you have triangle in a network, right? Triangle in a network means that you have such type of connection. Then there is issue related to loop. But if you have a straight line like this, then there is no loop, right? Although this is layer 2, but since two links are aggregated to one link, so that means that there is no loop, right? So if you have any question. Yeah.
Yeah, I see a lot of companies deploying the virtual switching.
Yes.
That's what I see.
So what you're telling that in your
So the virtual. Mm-hmm.
Yep.
I mean, what I see a lot of companies do is the virtual switching on the access layer.
Yeah.
Yeah.
Right. Yeah. So it's like how the design get evolved. So from here it got evolved to this, and now if you see new design, even we are also preferring this routed access, because in that case you have ECMP. Here, if you go and see this particular design, when you have the ether channel between the link, so it depends upon the link load balancer, like what type of load balancing method you are using. According to that, different application will go and get load balanced across the multiple bundled link. But here it's like true ECMP, and the convergence and the speed for the routed network is as per different research, they are telling that routed access has the best output, best throughput. So now that's the reason you will see, even you see that in data center, in below you will see that you have data center as a L2 in this diagram, but nowadays people are using ACI. So ACI itself is a routed access. It's not L2 access or communication. ACI within the fabric, they have L3 reachability. So likewise, everywhere, not only data center, but in campus area as well, in the LAN network as well, companies, they are redesigning the network to do routing reachability. Okay. All right, great. So good discussions going on, and this video is also becoming epic now. There are one or two more videos, and later on, obviously, in the configuration section, we have to go and configure it. Configuration, you will see that it's very easy, like 4 to 5 lines configuration, and it will work fine. Now, in this diagram, you can see that once you are using layer 3 distribution interconnection, what different type of features you can go and use, like tune, safe load balancing, summarize routes. These are the best practices. Load balancing, summarize the route, limit the redundant IGP pairing, STP route and HSRP primary tuning, set the trunk mode to non-negotiate. These are the best practices. When you are doing the configuration for your access layer devices, then you should go and do all these best practices. And few of the best practices we are going to discuss in our lab as well. Once we'll go and configure the lab. Like these are just the best practices, and for your reference, you can go and have a look on this. You will see here in this architecture, this is redundant architecture, this is logical diagram where we have redundant devices, redundant interface connection, and then in access layer we have redundant connection. Now if we are using some sort of VSS, then we can go and bundle these interfaces, no problem. If it is not there, then what we can do, for few of the VLANs, we can go and make this switch as a primary for VRRP or HSRP, and few of the VLANs, for example VLAN 20 and 120, this is the primary, and for VLAN 40 and 140, this will be the primary. So that means it will work as a active gateway for different VLANs. Right, like that we have the configuration. Not only you can make this as an active connection, but you can put some sort of tracking as well. You can put some sort of IPSLA as well. So IPSLA and tracking, those mechanism also we have the lab related to that. We'll go and check. Right.
Wait, 1 second. You said active.
Yeah.
Okay, so like both links might be active, but the VLAN only one is active. Is that what you're saying?
Yeah. So
Oh.
what we can do, that suppose you understand like this. So suppose you have one PC here, right? And suppose this is configured as a VRRP master and VRRP backup, master slave, like that. So what we can do, that for VLAN 20 and VLAN 120, you can make this switch as a primary gateway. You know, we are creating some sort of VIP IP, virtual IP for GLBP or HSRP or VRRP. So this can be the gateway. So the traffic for VLAN 20 and 120 will prefer in this way. Likewise, we can go and create the master gateway, master for VLAN 40 and 140 for this particular switch. So for VLAN 40 and 140, this having higher priority. So this is the master for certain number of VLANs, and for certain number of VLANs, this is the master. So that means that VLAN traffic can be load balanced, so they can work as a active gateways.
So in essence, you are using SDP priority to make the distributions prefer a particular VLAN.
Yeah, STP is there, that which particular switch is the master.
Okay.
So that is different thing. But when you suppose I have one laptop here, right? And this laptop is in VLAN 20. So in that laptop, you will go and put the IP address and the default gateway.
Oh, okay, I get what you're saying. So whatever so like the SVI for VLAN 20, the VIP on the distribution is going to be the gateway of that network.
Yes,
so they will
100%
use
right.
okay,
Yeah.
got it.
100% right.
So which means at any point in time for any VLAN, we are still using 50% of the capacity.
100% right. Yeah.
Yeah. So which protocol will make it active on both sides for every VLAN? Because I know like some companies like Arista has VARP, and that is active. So on Cisco,
So actually the only active protocol is GLBP, but it has some internal issues. Generally in production, you will see people are using VRRP or HSRP, but VRRP and HSRP both are working as an active standby or active primary secondary. So what we are doing to make this active for few VLAN, you can make a primary for one switch, and for few VLAN you can make primary to other switch. So in that case, active passive will work as a active.
Okay.
Okay.
Okay. All right. Good discussion. Great. So after that, we have few questions. So let me go and pause the recording and we'll discuss the questions as well.